Welcome to the world of science and technology. Today's topic of discussion is quantum spin liquids. No doubt it's an intriguing as well as a mysterious topic from the subject field of solid state physics. So magnets, you have idea about magnets. What happens in case of magnets? If we talk about those tiny magnetic particles, then what happens? Their spin either align in the same direction or in the opposite direction. So when their spin align in the same direction, means I am talking about the tiny particles by which the magnetic material or the magnet, say for example bar magnet is made. Okay. So when you think about those tiny magnetic particles, then in that case their spin either align in the same direction or in the opposite direction. When they align in the same direction, then they are actually that thing happens in case of ferromagnetic materials. And in case of opposite alignment, means the directions are opposite, then that happens in case of anti-ferromagnetic materials. Okay, so right now we are talking about only anti-ferromagnetic materials where this phenomenon is observed. It's really an intriguing phenomenon. If you think about a lattice of triangular shape, okay, say tiny magnetic particles are sitting on a triangular lattice, then what happens in that case? Each tiny magnet will try to what? Will try to align in the opposite direction. So only 3 magnets are there. That means it will not be possible for them. You just draw on your on a page this thing. Then you can easily understand that if the condition is like a triangle, in that case they won't be able to sit or align themselves in opposite directions. They will conflict with each other. So there will be a constant fluctuation. So this is a state of constant fluctuation. Yes, we are talking about quantum spin liquids. These are actually exotic states of matter. These are not normal states, exotic states of matter. And these are solids. Actually these are solids, but their behavior is like liquids because their spins do not settle. Means their spins never freeze or align or settle in a fixed position or in a fixed pattern. Okay, they constantly fluctuate, their spins constantly fluctuate. So I am not talking about those materials, I am talking about their spins. Since their spins are constantly fluctuating without any external disturbance to the material or to the system, that means their spins are dynamic in nature. And you know that in case of fluid motion, fluids are constantly deforming during the course of flow. So there is a similarity between the dynamic nature of their spins and with the fluid flow. And that's why these are called quantum spin liquids. This term liquid is used for that purpose only, for that reason only. Because their spins constantly move or constantly fluctuate. And it has been experimentally found that these particles, these tiny particles remain in entangled state, means I am talking about quantum entanglement. And this entanglement is so robust that scientists are expecting that this could be used in the field of quantum computing. Not only quantum computing, there are so many fields where this intriguing property could be used. Possibilities are there, such as for the development of new materials with extraordinary properties. In case of room temperature or high temperature superconductivity, this property of magnets, means I am talking about those antiferromagnetic materials where this intriguing phenomenon is observed. Okay, so many possibilities are there. Means there will be a drastic change by incorporating this special property of those antiferromagnetic materials. Example is ruthenium chloride, then Harvard smithite, that is another material where this nature or this property is observed. No doubt this is an elusive field of study, and how normally scientists study this field? By using neutron scattering technique. They can study this special behavior or special property of the material. Okay, then different measurement techniques are there, quantum measurement techniques are there, by which the scientists are able to study this special property. Okay, and anyway, so this was all about the topic quantum spin liquids. So what is the reason why these are being called liquid? Because the spins constantly fluctuate in the material, constantly fluctuate. They do not, they never settle in a fixed pattern. They never freeze. Okay, and that is the reason for which they are called liquids. Okay, actually they are not liquids. They are what? They are actually solid particles. Anyway, and one more term is there that will be discussed in a separate video. That is called magnetic frustration, because I have already mentioned that they conflict with each other. When in a triangular position, means we are talking just a few minutes back, I mentioned that a triangular lattice. Okay, so there you can see that the magnetic materials or the particles are constantly conflicting with each other. Okay, so that is a kind of frustration of the magnetic materials, known as a magnetic frustration. So magnetic frustration, this topic will be discussed in a separate video. Anyway, so this was all about today's topic, quantum spin liquids. Okay. And so this is the end of this video. Thank you for watching this video.